This video explores control processors and connectivity. The control processor is the brains of the operation. This is where the control program resides and all control points and devices are managed. To accomplish this, the processor must support various communication platforms. There are many different processor models, all based on the 3 series architecture. These models vary from simple controllers with limited connectivity options to full single-box solutions containing presentation switchers and amplifiers. The connectivity requirement of the system you're installing will determine which processor you choose to install. With that in mind, let's have a look at the different connectivity options available throughout the control processor product line. This video contains a brief overview of serial, IR, relay control, I/O ports, Ethernet, and CrestNet. The following sections in this class will discuss some methods in more detail. Shown here is the CP3 control processor. Here are the communication ports, commonly called COM ports. 3 are available on this processor. Serial communication can be bidirectional. This means that a control processor could send a command to the device and then receive a response from that device providing real-time feedback. Some COM ports can support different protocols. RS-232 is the most common protocol. Any device with a COM port supports the common RS-232 protocol. Some ports also support the RS-422 standard. This is less common, but still in use because RS-422 is a balanced communication that offers a greater distance over the RS-232 protocol. RS-485, like RS-422, is a balanced communication. This means that it is less susceptible to external influences, such as electrical interference or RF noise. An advantage of RS-485 is that it can do multi-point communication, meaning that many devices can be placed on the same network. Not all ports support RS-422 or RS-485. For example, on the CP3 shown here, there are 3 COM ports. The first supports RS-232, RS-422, and RS-485. The other 2 ports are RS-232 only. The specifications of each control processor are available on the website and show the standards supported by each port. Because the COM port supports 2-way communication, they are really useful for any device you wish to control directly and receive information from, such as a projector. Once a projector receives a command to turn on, it may be some time before it's ready to receive an input signal due to the warm-up of the lamp. Using a serial port for control allows us to present a message to the end user when the projector is warmed up and ready to display a source. Another common method of control is infrared or IR. Here in the CP3, we can see 8 IR ports available. Other control processor models may have less. Each IR port can connect to an IRP2 infrared probe. This probe attaches to the front of the device you wish to control. It allows us to send the same infrared commands as the original remote control. These IR probes operate up to a distance of 1,000 feet. Another advantage of using IR is that multiple devices can be programmed on a single port. We can attach 3 IRP2 probes to a single port. Be aware that if all 3 devices are the same, they'll operate simultaneously. This is unlikely the preferred operation of the system. However, perhaps if one room has a display, a Blu-ray player, and a games console, then all 3 devices can be operated from the same port. This means that the 8 ports in the CP3 can actually control many more devices. This is very useful when specifying your control processor. Infrared does have the disadvantage of one way of communication only. The control processor has no way of knowing that a device receives a command or that it's operating as expected. However, many consumer-level devices, such as Blu-ray players or games consoles, have no other method of control. Also, when used for the source device, such as Blu-ray, the user can easily see if it's playing after the button has been pressed. If it's not playing, simply press play again. It's also possible for the programmer to configure any infrared port to act instead as a one-way serial port. For example, the CP3 shown has 3 serial ports. However, perhaps the system has 4 serial devices. If only one of those 4 devices needs to be sent a command and will not return any information back to us, we can take advantage of a spare IR port instead. This feature, combined with the ability to put multiple infrared devices in a single port, allows the CP3 to be used even when there are more devices than there are ports. This may save the cost of using a processor like the AV3 or Pro 3 that has more communication features. The next method to look at are the low voltage relays. Again, showing us the CP3, we see on the very left-hand side the 8 relay ports. These relays connect directly to the device we wish to control. The relays available on most processors are rated at 1 amp 30 volt AC/DC. If you need to switch to a higher current voltage, other units are available. The distance is determined by the device. As it's a contact closure, we could be switching very low current or high current, which would go a bit further. Relays can be used for any device that requires a contact closure. Control processors also have digital inputs. There are two types of digital inputs depending on the processor. This information can be found in the processor specifications. The first type is a basic digital input. Using the contact closure input allows the processor to be aware if something has changed, such as a door contact in a partitioned room or a motion sensor. The second type is the VersaPort. The VersaPort does everything a normal digital input can do, as well as being able to read an analog voltage between 0 to 10 volts DC. This can be used in conjunction with a third-party sensor, such as a temperature sensor or a photocell. The VersaPort can also act as a TTL, or transistor-transistor logic switch. TTL devices are sensitive to a voltage change and are quite common in industrial controls. All 3 series processors communicate via Ethernet on a standard Ethernet network. Ethernet is very important to the modern Crestron control system. Many devices we communicate with are via Ethernet. We can use this to connect to other Crestron devices. We can also use it to control many third-party devices. As Ethernet is the standard protocol, many modern devices support it. The 3 series processors support many Ethernet standards, such as native BACnet, or Building Automation Control Network, IPv6, and SNMP. Devices on Ethernet can be connected to building management and monitoring software, such as Crestron Fusion. The use of Ethernet also allows control by mobile devices. In fact, Ethernet is so important, we have a whole other tutorial devoted to it. Lastly, we'll look at CrestNet. CrestNet is a 4-pin connection that can be found on many Crestron devices. CrestNet is a bespoke communication network that allows multiple Crestron devices to communicate at a distance of up to 3,000 feet or 915 meters. This is a maximum of 252 devices that can be added to a single connector. CrestNet is only usable with other Crestron devices. In the past, CrestNet was the preferred form of communication for other Crestron devices. While most devices now are heading towards Ethernet, CrestNet is still used, particularly in lighting systems and keypads. CrestNet will also be discussed in more detail in another video in this class. As we have seen, some communication types require single connection to each device, while others allow multiple devices on the same connector. These we call communication buses. A communication bus is a system that transfers data between components in a system. Devices on a bus communicate with a control processor and, in some cases, each other. Using communication buses reduces the amount of connectors we need, as one connector can communicate with many devices. In a Crestron system, there are 3 common buses: CrestNet, InfiniteEX, and Ethernet.